last webinar we were working with the bird class here, and stored into the program we have 4 different bird images. Just called it bird 1, bird 2, bird 3, bird 4, and we set the image of the bird at 1, and we set our counter to 0, and essentially every time we act, count goes up by 1. So essentially the way that we kind of fine-tuned it was that every 3 counts of act, the bird's image would change. So that's kind of one purpose of the count variable. When we set it back to 0 once it gets to 12, and then it repeats the process. So that's when we run, we get the 4 images rotating, alternating, and we get some kind of animation here with the bird flapping. So we're going to kind of go a little bit further with that. I want to look at the API for the Greenfoot image. So in Greenfoot image, these are methods that it can do. And one thing I think I know at least I want to mirror it at some point. We would want to mirror it horizontally. Let's see. Yeah, actually it'd be horizontally. Yeah, the left of the image becomes the right, and vice versa. And the reason we'd want to do that is when the bird changes directions, we can change its direction, but it won't change the image. So we'll have to flip that image. And the other thing I'd want to do, I'll probably do it at the very beginning, is scale. So whenever you scale an image, you give it 2 parameters, the width and the height. And if you wanted to keep the ratio the same, so let me just show a few things here. So back in my constructor, I set the image to bird. If I did, well actually, let me store Greenfoot image. This would be image equals new Greenfoot image, and I would pass this bird 01.png. So and if I just put image right here, then the code does exactly the same thing. What I'm going to try to do is scale the image. So you can see first, because right now the bird's probably too big, but so if I scale it at 30/30, we can take a look at it now. Oh, gotta call scale. Image.scale 30/30, and that completes that. So now when I reset, let's see, I didn't. Let me set the image to that. So now we're going to get a 30/30 rectangle for the image. So it's smaller than I want, so let me make it 50/50. But what you're going to notice is that when we put it as a rectangle, it looks a little different than before. Nothing that might look too obvious. By the way, the rest of the images aren't scaled, but the original image is. Well, what you could do to keep that same ratio is you can multiply the width by some ratio and the height by the same ratio. So the way that it works is you could do image.getWidth. I could multiply that width by, let's say, 0.5, and the height by 0.5. So essentially that would cut it at the same ratio. The width would get half the size, and the height would be half the size. So the whole image would pretty much be cut in half. And one thing I'm going to have to do here is cast that to an integer, which, because the scale method expects to get an integer, so if you multiply it by 0.5, which is a double, it's going to say I need it to be an integer. So I'm just essentially casting that number to be an integer. Okay. So now when we get it, that's the same ratio that it was before. And looks more like what size we'd want. Now again, all the other ones are the same, are the original size. So you would have to do kind of this same concept. One thing we could do is create 4 images, scale them all in the constructor, and then work from there. Probably the easier way would have been to scale it in like Photoshop or Paint one time, and then you wouldn't have to do it in code. But the scale method is very important, because sometimes you want to scale in the middle of a game. So maybe at some point you would want the bird to shrink, and then you couldn't do that in Paint. You'd have to do it in Greenfoot kind of in real time. Okay, so I think I will do that. Get us a good foundation. I'll create 4 images. Greenfoot image 1, and I'll do some copy and paste here, but 4 images of the same way. Bird 01.png. Okay, so I'll call that image 2, image 3, and image 4, and change that to bird 2, bird 3, and bird 4. So I got 4 now, and instead of doing that, that would be image 1. All these are image 1s, and then so I'll set the image, the original image will be set to image 1, but I'm also going to go through this process of scaling those other 4 images. Now that's not what the bird will look like, but if we ever want to use image 2, image 3, image 4, they will now be the right size. So this will give us a way to have all the images at the size that we want. Okay. And then the thing that I'm going to replace in the act method, as opposed to setting the image to the string, which would be that's whatever the original bird01.png. We're not actually changing that. We're just creating a new image and then changing it. So I can set these images, instead of bird 1, it would be image 1. This would be image 4. This would be image 3. This would be image 2. So now we got a better size for a bird, and every frame that it's flapping, we're going to see that. Okay. So moving on with Flappy Bird, the next thing we'd want to do is to get it to fall. So to apply some kind of gravity to it. So it's not really physics gravity, but it's just we're going to essentially decrease its y coordinate, and the way gravity works is it gets faster and faster and faster. So we're going to have some kind of velocity variable, and we're just going to essentially keep making the velocity smaller. So one thing you have to realize in Greenfoot is this is row 0, So I've put it up here and I inspect it. That says the y coordinate is 8, so I didn't put it up all the way, but if you put it all the way, it's 0. And the y coordinate down here is 395, so it's actually 400. Or 399 would be the lowest row. So it's kind of counterintuitive in that the y coordinate gets bigger as you go down. So we're actually going to add to the y coordinate of bird kind of over time. So that seems a little different at first, but that's what we're going to do. Okay, and that's the reason. So to strictly add some gravity, okay, I'm going to create a method called gravity. It's going to be a couple lines. So I'm going to add another variable to the bird object. Well, I guess I'll need to do 2. It'll be private double velocity. Let it be 0. And then I'm going to have this double gravity. So essentially what gravity is going to do is we're going to add that to velocity every time. So, and again, adding it is actually going to take us lower on the grid. So we're going to add it to velocity, and then pretty much we're just going to add the velocity to the y coordinate, which is going to again take us down. So gravity, I think we'd have to play around with it. If you did it as 1, it would be too fast. Let me try 0.4 first, and again I'll explain what's happening. But what I'm going to do in the gravity method is 2 things. One, I'm going to set the y coordinate of the bird to be a little bit bigger, which means lower. Okay, so the way that you set the y, there is no set y function in Greenfoot. Anytime you want to change a object's or a player's location, you have to call a method called set location, which set location changes the x and the y coordinate. It takes in an x and a y coordinate, but the x coordinate that we want is the same one. It's the current x coordinate. So gravity is not going to move us left and right. It's just going to take us down. So get the x coordinate, and then the other thing we want to do is get the y coordinate and then add our velocity to it. Okay. And when we add our velocity to the y coordinate, well, first off, velocity is 0, but we are going to increase the velocity by gravity. We're going to add the gravity, which is 0.4, every time to velocity. So as velocity gets bigger, slightly bigger every time, then the y coordinate is going to go down, and it's actually going to look kind of like gravity. Okay, so again, we'll just do velocity. You could do plus equals gravity. So what plus equals is if you had a variable int x equals 5 and you wanted to add 3 to it, you could do x plus equals 3. That's the same thing as doing x equals x plus 3. Both of these 2 things, if you had them, would give you what x would be 8 at the end of it. So right now I'm taking the current velocity and I'm adding gravity to the current velocity and assigning it back to the velocity. Okay. I'm getting an error message here because I need to cast. So again, velocity is a double, but just like the scale, the set location expects an integer. So I'm going to cast this whole thing to an integer. Yep. Okay. So that's all the gravity method does. It just adds every time it adds gravity, which gravity never changes, it's always 0.4, adds that to the velocity. And as the velocity gets bigger, it will continually add more and more and more to our y-coordinate. So we're not adding the same value for velocity to the y-coordinate. That's like acceleration, meaning the amount that we're adding to the y-coordinate is increasing. Okay, so let's take a look at that first. I'm hoping that's saved. Can only hope. Yes, it did. Okay, so this gravity method, gravity does not automatically happen. We have to include that into ACT because, as mentioned a couple times in Greenfoot, the thing that gets currently called is ACT. So if I just had a gravity method in here, it wouldn't change anything. The code would do exactly the same thing. But what I'm going to do is call gravity, just like that. I'm calling a method in the same class. So I'm just telling it to do that. So now, hopefully, what will happen is he drops. And you can tell, if you see it again, he drops slower at the beginning than he does at the end. Okay? Just how you would if you were, free falling. Acceleration is constant, but you get faster and faster. Okay? So, the only other two things I want to do is to give it a boost, which the boost will essentially subtract a good margin from the velocity. So, and again, subtracting from the velocity is actually going to push us up. So we're going to boost if we hit the space bar. So that's our space bar key is going to be like where we actually, he's always flapping, the bird's always flapping, but when you hit the space key, it'll actually, boost you up like you're flying. Okay, so I'll do that, and then the last thing that I'll do is to get it to move horizontally, and it will pretty much have the movement that we would want to end with. All right, so I just got to remember not to close that out next time. For some reason, this is doing kind of weird. All right, so called gravity. All right, the other one I want to do is flap. I guess I'll just call it flap. Okay, so what flap does, and I need to add, this value will also never change, just like velocity, just like gravity always stays 0.4. I'll do a private double boost, and I will call it 6 or -6. So again, boost is going to subtract from our y-coordinate, or subtract from our velocity, and our velocity is adding to the y-coordinate. So essentially, this will give us a lower y-coordinate, which is going to go up. This is how we will flap. Okay, so, or how we will fly. And it's just one line, essentially. We know how to take user input from the is key down method. And we're just going to see, which is called from the Greenfoot class, if is key down, I think space is actually spelled space. I might have to check on that. So if we hit space, we're going to let our velocity kind of like start over and be whatever the boost are. You could just do -6 there, but let's just call it boost there. Okay, so if we hit space, think about what's happening is velocity is going to become -6. And now wherever you were before, you're going to subtract from that. Now gravity is still going to happen. Gravity is going to add that 0.4 back to the velocity. It's going to steadily going down. So if you just flap one time, you're going to keep falling back. It's not like you're going to keep floating up. It's just going to boost you up and then keep falling, which is what we want to see. So So the thing I'm just going to highlight are these two up, because every time I minimize them, I lose them because they're coming up to the taskbar. So when I run now, same thing. It's not responding. Oh, I got a call. It's the same thing. I create this flat method, which hopefully will work, but only act happens. Okay, and there's a bit to doing everything in act. I guess I could have called like this an animate method, which this first part gets the bird to look like it's flapping. And I could call it animate, gravity, and then a flap, which are essentially doing that every time act is called. You could do it all in one place, but the benefit of creating multiple methods is you just kind of, for one thing, it does some other things too, but for one thing, it just kind of highlights the thought of this is just gravity, this is flap, this would just be animate, and you could just kind of think of them as, you know, separate entities. So there's some space keys, so we now we get it to flap. So you got to like several claps to get it, taps to get it to move over. Okay. So we pretty much have a flapping bird. Wings stay flapping. We have it where it's moving. The last thing we want to be able to do is to be able to go left and right